Good afternoon, all of you. My screen is visible.
Yes, sir.
Okay. In the previous class, we observed that analysis with grid control, but no overlap. So, if no overlap, what is the sequence? And with overlap, what is the sequence? If you know that logic, that's all this unit. Nothing is there. Only the device conductions, and based on that, what is our output voltage? If these devices are conducting, then we can easily draw the graph sheet and all. So graph means just what is the output voltage waveform and all. Now this is actually our circuit 6 pulse converter. If you are not considering overlap, then you may aware that in 3-phase full converter sequence, wherever you start, let it be 1 2 or 2 3 and so on, or 5 6, you can start anything. So the starting point onwards, let it be 5 6, then 6 1, then 1 2, then 2 3, then 3 4, 4 5 and so on, then 5 6. So now we can see 1 2 3 4 5 6, 6 pulses. If consider that no overlap between the devices. If no overlap, then what will happen? Only two devices will conduct. One device from upper group, another device from the lower group. So based on that, you can able to get it as a sequence of conduction. So this is the sequence 5 6 6 1 1 2 and so on. So now if that is the scenario, you can see that equivalent circuit if 1 and 2 is conducting. This is already explained. Just carefully understand this. If this is known to you, then we can easily observe if 3 walls are conducting, because this total scenario is some cases based on the overlap. If overlap angle is less than 60 degree, two intervals are there. First interval is 2 walls conduction, second interval is 3 wall conduction. That is the first overlap period is less than 60 degrees. Preferably that is the case actually. Suppose if overlap angle is equal to 60 degree, all the cases 3 wall conduction takes place. Then overlap angle is greater than 60 degrees, again two intervals. One interval is 3 wall conduction, another interval is 4 wall conduction. So that is the procedure. Now before going to that, if no overlap is takes place, how to find wall voltages, then each phase currents, then voltages and output voltage, that is a VD and ID. So all these things you can easily obtain if you know simply if two walls conducting. So now the thing is here I shown you two walls are 1 and 2. If walls are conducting 1 and 2, then we can observe here. I will take a mark. Yeah. See, wall 1, this one is conducting, and I will ask you to say your answer if other walls are conducting. Let it be 2 and 3 is conducting. First, if it is a 1 and 2 is conducting, we can see that because all the cases we need these equations to plot. But in textbooks they given directly output waveform, but you must know how that waveform will be obtained if the overlap changes or wall conductions are changed, then what is the output voltage and what is the wall voltage. All these things you must aware, but it is very simple logic. You can see this is conducting, 1 and 2 is conducting. We can notice that current, IA current is nothing but I1 current, because whatever the device current is there, I will represent as a same name. So wall 1 current is I1, wall 2 current is I2, like that. Then you can see IA, IB, IC are the supply currents. So now IA, it goes to I1 only. So therefore IA is equal to I1. Then again where it will go? It go to the load, then it is from I2 wall to out. So now we can see that same current, it goes to I2 also. That's why I mentioned I2. Then what about IC? IC is here. IC direction and this direction is different. So that means here we can notice that we are entering in this opposite direction. This arrow mark and IC current direction both are in the opposite. That's why I mention as a minus IC. Then the load current, this is ID current. So therefore that current is equal to ID only. So I1 current and ID current, I2 current, everything is same, but IC current is just opposite sign. That's why I mention as a minus. So this is the case. And now similarly, suppose if any particular instant 2, 3 is conducting, then what is the IA, IB, IC or V1, V2, V3 and so on. So that you have to analyze in the particular instant. And now see that IB. What is the IB? Now IB is this one. So where it will go? It will not go to I3 or it will not go to I6. What is the reason? Because these two walls are open. Only conducting walls are 1 and 2. So current we must pass either one and through wall 2. But other walls are off state. So that is the reason you can see that IB, and then all other currents of non-conducting walls are 0. It is very blind thumb rule. Conducting wall currents are same. It has to pass through that because two wall conduction only, and rest of the walls, whatever the walls are not conducting, let it be 3 is not conducting, 5 is not conducting, 4 and 6. So rest of the currents are zeros. And similarly, that is about the currents. Now we'll come to the voltages. So what is the VA voltage? So this is the VA, this one is VB and this one is the VC. So VA is equal to VP. Why it is VP? Because VA is directly connected to here. Because wall 1 is already conducting state. So VA is same as VP. And similarly VC is directly connected to the this point, that is a VN point. So that's why VC is equal to VN and VA is equal to VP. And that also same as this voltage, let it be EA. EA is nothing but we observed in the previous slide, EM cos omega t plus 60 degrees. EC is equal to EM cos omega t minus 180 degrees, like that. So EB is equal to EM cos omega t minus 60 degrees. So that is EA and VP and EA is our same. That is the just supply. And EB case you can see that it is not connected to either VP or not connected to VN. That's why just same magnitude will be there. That magnitude is nothing but a EB magnitude. So now this portion is related to the VA, VB and VC. Now once if you know that, I want to know what is the VD. VD means voltage across this. How will you get VD? Now we can see this pole and this pole I want. So difference of this will give as a VD. So that is nothing but a VP minus VN, that will give as a VD. Very straightforward question. So VD, VP minus VN. VP is nothing but a EA. VN is nothing but a EC from this, and just subtract that A minus C, that is nothing but a EAC. EAC is already calculated in the previous slide. Just substitute and expand cos A minus B format and then cos A plus B format. You can get it. Just root 3m cos omega t plus 30 degrees. This is the VD. And now wall voltages are very simple. Conducting wall voltages are 0. Rest of the wall voltages we have to identify where it is connected. That's all, simple way. Now conducting walls are V1, this is conducting 0 and this is a V2 conducting. So voltage across V1, voltage across V2, 0. So just I mention it is a 0. And what about voltage across V3? V3 is nothing but a 3 valve conduction. So voltage you have to measure with respect to the anode. So now where the anode is connected, where the cathode is connected, that is nothing but a voltage across valve 3, and similarly rest of the valves also. Now we can see for 3, third valve, anode is connected to where? VA, means it is nothing but a VB, anode is connected to VB, it is also same as the EB. So therefore EB, and anode is connected EB, and what about cathode? Cathode is connected through valve 1 to VA, that is nothing but a EA. Then valve 3 voltage V3, that is nothing but anode potential, let it be as a EB, and minus cathode potential is a EA, let it be, this is the valve 3 voltage, so that is nothing but a EBA over, that is the valve 3. Similarly you can see for other valves, let it be as a valve 4, because 2 already conducted. Let consider valve 4, where anode is connected, valve 4 anode is connected to VN and cathode is connected to A. A is nothing but what? That is nothing but a D only, VD. So therefore voltage across this is same as the output voltage, but the signs are different. Why? Because I am measuring with respect to anode. You can just carefully observe. If you have any doubt, you ask me. Anode is connected to VN, cathode is connected to valve 1, through valve 1 it is connected to VP. Now where that valve is connected across P and N, but N is a anode, therefore we can write V4 is nothing but a Vn minus Vp. But what is the Vd? Vd is nothing but a Vp minus Vn. Therefore Vn minus Vp is nothing but a Vd minus Vd. This is our output. So we can easily measure V4 is nothing but a minus Vd. What about V5? This also directly connected to the cathode is connected to the VP and anode is connected through valve 2 and Vn. Therefore voltage across this again same as the Vd only. But what is the Vd with respect to anode? It is connected to the neutral pole, negative pole. So that's the reason again we'll get it as a minus Vd. So like that we can easily identify. Suppose the question is let walls are conducting 2 and 3. What is the V1? Anybody? Wall number of walls are 2. One is upper group, another one is lower group. Wall 2 is conducting and wall 3 is conducting. Instead of 1, now you just make it as a 3. That's the difference. That's all. These two are conducting. This one. Now my question is, what is the V1? How will you get V1? V1 means voltage across the wall 1. Earlier V1 is, you can notice here, is 0. Why it is 0? Wall 1 is conducting. That's why wall 1 voltage is 0. For the wall 1 and 2 is conducting. Now I am asking, if walls 2 and 3 are conducting, then what is the wall 1 voltage? Wall 1 voltage, anode is connected to the EA and cathode is connected to the this point. So you can see that cathode, let it be, it is also connected to here, VB. Now what is the wall 1 voltage? This one, anode is VA and cathode is VB, because 3 is conducting. It is nothing but a, now V1 I can write anode potential is a EA minus cathode potential is a EB. Then what is your output voltage? EAB. This is for V1. Then what about V2? means second valve. V2 means second valve because it is already conducting. V2 is a 0. Then what about V3? V3 also conducting, that is equal to 0 because valve numbers are 2 and 3 are conducting. What is this I am asking? So 1 is VAB, 2 is 0, 3 is 0. Then what about V4? V4 is this one. Anode is connected to, let it be as a C. That is nothing but I am asking as a V4. This is connected to C. So V4 is equal to, anode is connected to EC minus, where is the cathode? Cathode is connected because this 3 is connected. Yeah, this one A. So that is nothing but a A. So therefore V4 is nothing but a E C A is your output. Once if you represent the graph sheet line to line voltage in any particular instant, you know what the devices are conducting. Accordingly, you shade only these portions, whether you are to shade AB or CA or BC, whatever that particular instant. So like that you can easily obtain. Then what about VA? VB, VC, VP, VN and VD. So you can see same version of previous version. VD, where it is, I am asking what is this voltage and what is this potential. So that will give as a VD. Now the number is connected to 3. No, this is on. Let it be, this is the point is connected to EB and another point, neutral point is connected to this. Now what is the output voltage? This voltage minus this voltage is a VD and VP is directly connected to the EB and VN is directly connected to the EC. Then output voltage is equal to EBC over. This is your output voltage. So you just shade the EBC. So like that, any particular instant, if two devices are conducting, that means not overlap, either it in the upper side or a lower side, you can easily identify what is our output voltage or what is our valve voltages and what is the currents. Everything current will be there whenever the device conduction. By default, if current is valves are not conducting, current is 0. So that way, so this is just brief introduction. Already I explained 1 and 2. If it is 2 and 3 is this way, like that 3 and 4, 4 and 5 like that, you can able to get it. This is the analysis. Now we'll come to this part. Just that's what I explained here in the previous slides. What is mentioned here is if only 60 degrees the set of devices are conducting. The sequence are let it be wherever you can start, then 2, 3, 3, 4, 4, 5, 5, 6, 6, 1 and again 1, 2. That is our conduction. So if no overlap, this is our sequence. We can start somewhere, depends on alpha, and from that point onwards you can able to identify what is the output voltage if no overlap takes place. And each one will conduct only the 60 degrees. So now instead of 1, 2, if I change to something else, 2, 3 or 3, 4 or 4, 5, 5, 6, same as previous, only suffix, prefix we can able to change it according to our magnitudes of your, this is your equation 3. In this equation 3, whether 1, 2 is replaced by 2, 3 is conducting, what is the VA, VB, V1, V2, V3, all these things will slightly modify according to your previous third equation only. Just you can notice the which device is conducting, where it is connected, that is only your output voltage. If all 1 and 2 has been conducting, then after 60 degrees what will happen? Let it be initially 1 and 2 is conducting. Let consider 1, 2 is conducting. This is 60 degrees. After 60 degrees, what will happen? Who will conduct? 2, 3. After 60 degrees, 3, 4. So this is the sequence. Now 1 and 2 is conducting. After that, 1 is going to be turned off and 3 will be turn on. So that is what I mentioned now. Ignites is nothing but a conduction. So 1 is replaced by 3, then 2 is already there, then 1 is gone, only 2, 3 is going to conduct. If 2, 3 is conducting, then that is the reference. From that you can able to find what is the wall voltages, currents, output voltage and all. So once wall 1 is completely turn off, then what will happen? You can able to delay that alpha, you can give it to fire the next set of the device. So that way you can able to find. And similarly next, if 3 is turn off, then what will happen? 4 will fire, I mean sequence 3 4, then 4 5, then 5 6 and so on. They mention at this point is omega t is equal to 0 instant, then you can add omega t is equal to alpha, then alpha plus 60, then alpha plus 120. Why it is 120, 60 and all? Start with 0, then you can add alpha, then every instant that alpha plus 60 degrees, each pulse will be 60 degrees. That's why I mentioned alpha plus 60, then alpha plus 60 plus 60, then 120, then 120 plus 60 and so on. So all these things is going to be added, because each pair of the device is going to conduct only the 60 degrees. That's why I am adding like that. And now the instantaneous direct voltage VD across the bridge, we observed the circuit diagram. VD is directly across the bridge voltage, that is difference between positive pole minus negative pole, where the positive pole is connected and where the negative pole is connected. Based on the conducting devices, you can get it as a what is your output voltage. Here we notice that your output voltage is not a phase voltage, it is a line to line voltage. So that is very important in case of bridge rectifier. Line to line voltage is your output voltages. And now, as in that diagram, in the previous diagram I shown, now if any valve is conducting, means overlap is taking place, that portion. So let you can consider this is the portion. You can able to integrate. You can get it as a what is your average output voltage. So that is in the diagram 3 I already shown you. So based on that you can get it there. Now you can simply just integrate that portion, because that area you have to integrate from minus pi by 3 to 0, because in that diagram if you see you can get the limits. And why it is a 3 by pi, actually it is a 6 by 2 pi, that I can write it as a 3 by pi. So why 6? 6 pulses are there. If it is a 3 pulse converter, 3 by 2 pi, 6 pulse converter, 6 by 2 pi, 2 pulse converter, 2 by 2 pi. Like that you can get it as a 3 by pi, or you can say that 6 by 2 pi, and then output voltage during that any particular instant. You can integrate AC is here. Suppose some other interval, if you change the limits, automatically your instead of AC it will become as a BC or CA or AC, all that depends on your waveform. 3-phase line to line voltages you can integrate. For the AC we will get it as a VA minus EC. If you subtract that you will get root 3 m cos theta or omega t plus 30 degrees, and you substitute the limit you will get it as a VDO. So here is a average direct voltage without overlapping instant, ideal case I am telling. So that will get it as a VDO. In this magnitude into EM, EM is a peak magnitude, that is a maximum value in the peak. So alternating voltage in terms of line to line. Suppose if you want to change to the what you call it as line to line voltage to the line to neutral voltage, and you can see that how the waveforms is going to be shift. It is all about 3-phase controllers only, but once overlap is taking place, these wall voltages, all these things will affect. Output voltage also going to be affect. That we'll see after this slides, means the without overlap case, this one. Now let me start somewhere alpha is equal to 0. So how we can able to get alpha is equal to 0? So this is the crossover point. From that you can shade the AB. Then if I shift this alpha from this point to something this point, then what will happen? This is your output. Still if we shift to this, then this is the output. Like that I am go on shifting. You can see that alpha is equal to 30 degrees. Then alpha is equal to 60 degrees. As per power electronics logic, for 3-phase full converter, alpha is equal to 0 all 6 pulses like this, and alpha is equal to 30 degrees will be like this, all 6, and alpha is equal to 60 degrees, it reaches as a natural 0. Beyond that, if I fire alpha value, if it is RL load, you will get it as a negative conduction also. 90 degrees means 3 root 3 Vm by pi into cos alpha. With that logic, alpha is 90 degrees, cos 0 is a cos 90 is 0, then output voltage 0, therefore positive magnitude and negative magnitudes are equal. So that is the reason we will get it as a, this is the 90 degrees case positive as well as the negative magnitude, and so on. If alpha is equal to 120 degrees, we will get it as a negative peaks, and 150 degrees little bit hanging, and then if it is 180 degrees is nothing but a cos 0. So cos 0 will give as a 1, cos 180 will give as a minus 1. So that is the reason it will come back to as a same as alpha is equal to 0, but it is a positive magnitude, it is a negative magnitude. So this is the variation of alpha for two value conductions. Two value is nothing but a, one is positive, one is negative. No more overlap. Let assume that no overlap, but practical case it is there. We will see after this. So now this is the variation of the voltages by changing the firing angle. Now just I converted into line to neutral. Now we will get this is the expression 1.35 into ELL, and now VDO is usually called as a no load direct voltage. So now if you for the any delay angle of alpha, integration or simply increases from by replacing the alpha. So that is only the thing. Now we can see the limits is going to be changed. Finally V out is going to modify to this V out or Vd, that is equal to Vd naught into cos alphas. There is a factor come into the picture to control your output voltage by changing this alpha. So Vd naught is ideal case, and by multiplying cos alpha, that will give as a variable output voltage by changing as a alpha value. One effect of delay ignition is to reduce your average output voltage in terms of the cos alpha, because if I change the alpha from 0 to something else, if I keep it 0, then your Vd is equal to Vd naught. But changing this, then output voltage is reduced the factor of cos alpha. So alpha is 30, cos 30. Alpha is 90, cos 90. So then output voltage varies with respect to that. So that's what the variation is going to be takes place here by changing the alpha. Cos alpha varies from -1 to +1. If I put alpha is 180 degrees, it is a -1, and 0 is a 1. So that's why variation is a 1 to -1. So then Vd can also be changes from Vd naught to something minus Vd naught. So that is the variation. So now we can see that analysis of with losses in the converter neglected, then what will happen? The AC power must be equal. So if no loss, let assume that AC input power is equal to the output power. What is the input power here? So there is a AC supply is the input. Output is a DC supply. As we derived that VD expression, this is your VD expression. VD just now in the previous expression output side, VD naught into cos alpha. That is your output expression. So now just I replaced that Vd into Id. Vd is replaced by Vd naught into cos alpha. Id as such you can keep. So from this you can see that what I mentioned is IL1 is the RMS value of the fundamental frequency component and in the line current. Line current has a wave shape and the positive and negative rectangular pulses in the ID. So there is a 2 pi by 3 in the sense. So you can get it in the current waveform whether 2 3 or a 3 4. So each cases 2 will be there, or 1 2 and 2 3. There is a 2 times it will conduct. Then there is a 120 degrees conduction takes place in the each device. The pair of devices are 60 degrees, but each device will conduct as a 120 degrees. So in that simplification, you can get it as a what is the IL1? So that is equal to 1.11 ID by root 2. So then variation of the current with respect to the alpha, we can see that the currents will be in phase in EA, and later if it is going to be changed the alpha value, then the current waveform also going to change, because instead of starting current drawn from the source at this point, it will get it as delayed by alpha, and again the alpha is increasing gradually, so the delay also going to be shifted. So that is only the variation you can see. Instead of starting here alpha is 0, now alpha is 30, now alpha is equal to something 60, and so on. You are keep on varying the alpha value, that it is going to be shifted. Now that is only the explanation I given here. The converter operation as a sort of transformer having the fixed current ratio, the voltage ratio, ignition delay imposed by the control grid. So only the thing is without overlap period, alpha is going to be varies, your output is going to vary, but formula will be Vd is equal to Vd naught into cos alpha, and that case is without overlap. Now we'll come to the picture of with overlap. In the with overlap case also, there is a 3 possibilities I mentioned. So what are the possibilities options? With overlap, U or a mu that is less than 60 degrees, and U is equal to 60 degrees, then U is greater than 60 degrees. So this is what we can able to analyze. Now first case, what I am considering is less than 60 degrees. So if U is less than 60 degrees, as I shown in the previous what we call it as overlap instance, if I see the diagram, in the to get one full average output voltage, within a 60 degrees of interval, 2 sub intervals will come into the picture. So that must be very clear. All of you must note this way. Let 5 4 4 5, then 5 6, then 6 1, then 1 2, and so on, any particular instant, then 2 3 3 4. So this is the sequence if no overlap. Now the overlap is considering any particular instant, you can take it, either it is 1 2 or 2 3. These are the 1 3 5 walls I am telling. 4 6 2, this is connected to A, let it be A phase, B phase, and then C phase. So in that case, let 1 2 is conducting, then actually if no overlap means 1 2 will conduct 60 degrees. Initially 1 2 is conducting complete 60 degrees, but now due to leakage inductance or leakage flux in a transformer, there is an inductor in a source side, it will continue to conduct some more duration because sudden changes will not allow. Then what is the change after 1 2? Normal case there is a 2 3 will fire, but now 1 and then 3 changeover or commutation is going to be takes place. 1 is going to turn off and 3 need to fire. Between that 2 3 case, we'll get it as a 1 2 3, then 2 3. So is it clear? So in between 60 degrees, after 1 2, then there is a normal case 2 3, then 3 4, then 4 5, then 5 6, then 6 1, and so on, then 1 2. So let it be 1 2, then 2 3. Between 1 and 3 together will fire, then the interval is 1 2 3 interval come into the picture, then 2 3, then 3 4 between, then what will happen? Changeover is taking place, 2 3 4. Now all 3 devices, then again 3 4, then 3 4 5 will fire, then 4 5, then 4 5 6 will fire. Now we can see like that 5 6, then 5 6 1, then 6 1, and so on. So now you can see that here what I want to do to get average output voltage, whereas in the previous case to get average output voltage, once 1 2 is conducting or 2 3 is conducting or 3 2 3 4 is conducting anything, you will get same duration of pulses. You just integrate by multiply by 6, you will get it as average. But now, how many? Total is 60 actually. If suppose this duration is something, then this duration is mu or u, whatever. Then what is this duration? Anybody? If 1, 2 without overlap, 1, 2 will conduct 60 degrees. But now there is a overlap of u is some degrees. Then how many degrees 1, 2 will fire? How many? 60 minus u. Because u is overlap. If you no overlap, u is 0. Then 1, 2 will fire 60 degrees. If there is a overlap 10 degrees or 20 degrees something, then 1, 2 will conduct only 60 minus u. This is the case the devices are conducting. Now you know what is the voltages for 1, 2 is conducting. Then you have to identify if 1, 2, 3 is conducting. See, in the previous slides, 1, 2 is fire. I given as a list of voltages and currents and average output voltages like VA, VB, VC, EA, EV, EC, then V1, V2 up to V6, IA1, IA, IB, IC, then I1, I2, I3 up to I6. All parameters are known to you if 1, 2 is conducting based on your equivalent circuit. Similarly, what I want to know is if 1, 2, 3 is conducting, I want to know what is the V1 to V6, then VA, VB, then VC, then VD also I need, that is nothing but a VP minus VN, then IA, IB, IC I need, then I want I1, I2 up to I6. All these quantities I need if 1, 2, 3 is conducting. Therefore, average output voltage how will you get it? Previous case average output voltage only 1, 2 is conducting. I substitute the limits, I got it. But now average output voltage of a controller, if I want to know under overlap condition, what I want to do is I want to integrate if all 1, 2 is conducting average expression plus then 1, 2, 3 is conducting what is the VD. Here what is the VD? Here what is the VD? And add these two, we'll get it as a final average expression of a controller if overlap is considered. Any particular instant, there is a 2 intervals is taking place. 1, 2 is conducting plus 1, 2, 3 is conducting. When 1, 2, 3 is conducting, output voltage will be reduced when compared to 1, 2 is conducting. 1, 2 is conducting directly line to line voltage and 1, 2, 3 is conducting. Let 1 and 3 are in the same positive group. So this will take it as average of this because short circuited under that particular phases. So then our average output voltage is going to be reduced during the overlap period. Then our VD is nothing but a just integration of 1 and 2 is conducting what is the voltage plus 1, 2, 3 is conducting what is the voltage and you can able to get it over. So that is the logic we need to explain here. That's what now once if you know that individual valves, voltages or currents and all, you can easily find what is the current expression means instantaneous current, instantaneous voltages I need to measure first. Then you will go for as average. Now that's what I mentioned here. AC source, especially there is a transformer in that source side as inductance. Due to that, there is a finite duration overlap is going to be takes place. Current in it can vary only at a finite rate. So that what will happen, your current is transferred from 1 to 3. Some time is required to complete transfer the valve current from 1 to 3. Like that, if any what you call it as negative group devices also want to change, let it be 2 to 4 or then 4 to 6 or 6 to 2 again, whatever we want to transfer, we require as a some time duration. Then what will happen, current from one phase to other phase required as a some time. That time I call it as a commutation time or a overlap time. That overlap omega t is equal to u. Therefore, time is equal to u by omega. So that is only the overlap is nothing but a incoming device and outgoing device together will fire some duration, or current transfer from one valve to other valve, it will require some time. That time we call it as a overlap time, and that normally is always less than 60 degrees in general case I'm telling. So full load valves under that particular condition, the overlap angle only 20 to 25 degrees it will be there. So in the general cases, but extreme case, if anything is happened, there is a chance of getting beyond 60 degrees or equal 60 degrees. We will observe on each particular instant what will happen if overlap angle is increases, then automatically average output voltage will decreases. And as you know that in the diagram previous, I will show that now, and without overlap with just today class itself I show, no, I will show just now. This is the thing. And what is observation is here, without overlap 5, 6, 6, 1, 1, 2 and so on it will conduct. And with overlap, what will happen? Instead of turn off the device here, it is continue to conduct some more time. Therefore 5 and 1 together will fire, and 6 already there, then 5, 6, 1 is going to be conduct. That is the case if 3 valves are conduct. After that again 6, 1 will conduct. Then 6, 1, 2 will conduct. Then 1, 2 will conduct, like that. So based on your alpha, you can see that alpha is equal to 60 degrees. There is a upper group overlap and lower group overlap. Both is takes place at the same time. If it is beyond 60 degrees, then 4 valve conduction also going to be happened. So this is the case. 4 valves are conducting positive overlap taking place, negative overlap taking place. Therefore 5 and 1 together will fire, and then 6 and 2 together will fire. So therefore all 4 valves are going to be conduct. So this is all 3 valves are going to conduct. But whereas here alpha less than 20 or let it be alpha less than 60, you can notice that one time upper what you call it as overlap, and rest of the time one upper one lower. So that means here 5 1 is overlapping and 6, therefore 5 6 1 3 valves are conducting. After overlap period is over, then only 6 and 1 is going to conduct. Like that we can easily find what are the instants you can able to find. That's what I mentioned here just for understanding. If u is equal to 60 degrees, this side I wrote. So there is a, in this between, since new commutation ever 60 degrees totally, in that one is conducting some duration, the rest of the device means 1 and 2 is conducting only 60 minus u may be overlap angle, it may be 10 degrees or 20 degrees. Then the sequence is like this. Just I drawn the previous slide. This is the sequence 1 2, then 1 2 3. This is the overlap period. Then 2 3 non-overlap period. Then 2 3 4 is overlap period, and then non-overlap period and overlap period, like that. We can observe that to get one full interval or one full cycle, there is a two options are there. One is a overlap interval and non-overlap interval. So you just take it of any duration 1 2 and 1 2 3, or 2 3 and 2 3 4, or 3 4 and 3 4 5. Any particular interval if you integrate, automatically you will get it as an average expression. That's what you can see here. If u is equal to 60 degrees, then what will happen? Only 3 valves are going exactly 60 degrees. Always 3 valves, just based on the previous diagram. You can notice later also. So just less than 60 degrees. One is non-overlap interval and followed by overlap interval, and exactly 60 degrees all 3 valves are conducting, and this is the sequence if what you call it as exactly 60 degrees, and beyond 60 degrees let it be up to 120 degrees or whatever. So there is a 60 to 120 degrees mode of operation that occur 3 and 4 valve conduction. So means some duration upper will conduct, and then followed by normal non-overlap period, and then followed by lower as well as the upper valve conduction. I mean changeover. So in the both sides changeover, let it be 1 2 3 changeover, then 2 4 changeover. Then what will happen? 1 2 I mean 1, 3 will conduct together and 2, 4 will conduct together. Totally 4 walls are conducting. So that is all about depends upon the alpha, or I mean what you call it as overlap angle. You will decide how many walls are conducting. And in this case, we consider specifically less than 60 degrees. We need to consider 2 wall conduction and 3 wall conduction. Therefore, 2 by 3 wall conduction need to explain and to derive that. So now I will consider 3 wall conduction, because already 2 wall conduction are explained in case of non-overlap case. That is similar by I already mentioned no 1 2. If it is a 2 3, what is outputs, or if it is a 3 4, what is the output? You are familiar in that part. Just conducting devices currents are present and conducting devices voltages are 0 and non-conducting devices currents are 0. Like that, you just go with thumb rule, and then wall voltages V1 to V6. Conducting walls voltages are 0, non-conducting wall voltages are across. Anode is connected to where and cathode is connected to in which phase. That is anode to cathode, subtract, you will get it as a wall voltage any particular instant if that particular walls are conducting. And now we can see here, let 1 2 3 are 5. First 1 2 is conducting and then you are firing as a third wall, then the overlap takes place 1 and 3 and 2 remains there. Therefore 1 2 3 is conducting. Then what is your sequence? Now before overlap, now you can see this equation very simple. This is the case will arise this one. Let we can consider 1, this is a 3. What is meaning here? First it carries the ID current, load current, because one is only conducting upper side, lower anyhow second device is there. Then during that instant there is a overlap is taking place. Then 1 is going to down and 3 is going to rise. So first instant I1 is equal to ID and I3 not yet started, let it be, it is a 0. And now you are overlap during overlap period, and after completion of the overlap period, now you can notice that overlap period is alpha plus mu. Let for simplicity delta is equal to alpha plus mu. What will happen? This is the interval of mu. This is the interval of mu. This is the alpha, and this point I can write as a alpha plus mu. So now alpha plus mu, what is the current? I1 current is it reaches to 0, because during overlap there is a current, but once overlap is ended, then your current reaches to 0. But what about I3? This current is reaches to the ID. So therefore this is the instant during overlap. So that is the point. So now this is the equivalent circuit. Earlier equivalent circuit and this equivalent circuit slight different is there. In valve 3 earlier I make it as a open, so it won't there any current. But now valve 3 also conducting. This diagram is only during overlap. Once overlap is ended, then one will be off, one will be not connected anywhere, and then let 2 and 3 is going to be conduct. 1 2 then 2 3, no, so 2 3 will conduct. That diagram is same as the previous equivalent circuit. Instead of 1 and 2 you make it as a 2 3. But now this is the another diagram. If 1 2 3 walls are conducting, now we can see this current. There is I1 current plus I3 current, that will give as ID current. See that total ID is nothing but a I1 plus I3, that will go as a ID current. So that ID current is nothing but a minus I2 current. So this current is no same, let it be same direction. IC minus IC current. You can see that ID is equal to minus IC. Then IA current, and that is equal to I1 current. IB, that is equal to I3 current. Then you just find all the wall voltages and currents, everything, by considering as a 1 2 3 walls are conducting. Wall 1, wall 2 and wall 3 are conducting. Then what is your output voltages? Now you can see alpha plus mu. Just I am taking as a loop here. In this loop, we can write the equation. I am writing this during overlap only. Overlap case, it is very simple logic. What I can write is I1 plus I3, that is equal to ID. This is one equation. I1 plus I3 is equal to ID. So di1 by dt plus di3 by dt is equal to 0. That is one equation you can write. And now if you apply the loop in this, what is the loop? We start with n, then 3, it will go like this. In this loop, what is the voltage? EA minus this is EB minus EA, that is equal to inductor or source reactance based on the leakage current or based to the transformer leakage current, we'll get this. Then LC di3 by dt minus LC di1 by dt, because inductor LdA by dt, no, with that logic you can get it. So once if you know that, you just simplify that expressions, and you can, and also one relation is already known to you. Our intention is to find overlap, and then LC take it common this side, and what is the A minus EB minus EC is known to you, that is equal to root 3 into M sin omega t. Based on that, this EA minus EB is nothing but the EAB. EB is known, EA is known, just subtract, we'll get it as a root 3 M cos omega t minus 90 degrees, and this 90 degrees you will make it as a sine, because cos 90 will become as a sine, because odd number. So let root 3 M sine omega t. This is the here. We can substitute here. Will LC will come this side. Then what I can write, root 3 M by LC into sine omega t, that is equal to di by di3 by dt minus di1 by dt. And here you can apply differentiation. Then what I can write, di1 by dt plus di3 by dt, that is equal to 0, because id is a constant. And you can write here something, what I can write, d I3 is here by dt and minus di1 by dt, that is equal to what I can write, root 3 M by LC sin omega t, and you just add this will get cancelled out. Then what will happen, di3 by dt plus di3 by dt, 2 di3 by dt, that is equal to root 3 Vm by LC into sin omega t, and substitute the limits, we'll get it directly. That's what I mentioned here. Same, this limits 0 to I3, then di3 d and integration will get cancelled, that is equal to I3. As you know that I1 plus I3 is equal to total current, ID current. This is the ID current, that is equal to, this is ID. Then what I can write, I3 plus I1 is equal to ID. Therefore, I3 is equal to ID minus I1. This is expression, I got it. Just simplification here. And IS2, just for simplicity, instead of writing every time root 3M by 2 omega LC, I just replace that IS2. That is nothing but a current. So root 3M by 2 omega LC, just I taken as a notation. Anything you want, you can repeat every time this value here, and you'll get. So now what are the quantities I want to find? Now as of now, I know what is the I3, and rest of the quantities I have to find. During commutation, line to line voltages of the short circuit, because what are the line to line? These are the commutation. A phase as well as the B phase are a short circuited because these two are incoming and outgoing devices are current is there, then together will fire, then therefore short circuit phase is a 0, and 2 line to neutral voltages are equal to the average of the corresponding output open circuit voltage. Now you can just simply, these two are on, what I will write? Voltage across this, what you call it as a VA, this one. We'll write VA, and this voltage is VB, that is equal to, because I am writing this because both are in parallel, then the average of that will give as your output. What is average? EA plus EB by 2. And you know what is the EA, what is the EB, you know, then simplify this, you will get it as EM by 2 cos omega 2, and EM by 2, EC is nothing but EM cos omega t minus 120 degrees. Then you can simplification, I can write minus EC by 2. So therefore I know now VA is equal to VB, that is equal to minus EC by 2, or 0.5 minus 0.5 into EC. This is the case 3 valve conduction. And then I3 already we calculated in the previous slide. You can see here, yeah, this one I3 is nothing but ID minus I1, that also called as a, just you can write ID minus I1, that is equal to IS2 into something, that is the factor, like that. That is the I3 current. So what about rest of the currents and other currents? Suppose 1, 2, 3 is conducting, then what about 4, 5, 6? That is all zeros. So this is the case if 3 valve conduction. So this is only the 2 things are required. Once if you know that, you can easily derive your expression. So now we can see that according to this equation, IA, this is the current, it goes to the I1 because it is conducting. But what is that I1 current? It is not equal to ID, but ID minus I3, that is nothing but a I1 current. You can see according to here, I1 plus I3, that is equal to ID. That's all. So from this, IA is equal to I1, that is equal to ID minus I1. So that ID minus I3. So this is equal to I1. Then ID minus I3, I just we derived in the previous expression, we made it. And IB, where is the IB? This is the IB current. IB current is nothing but a I3 current. So I3 current already we derived, because this I3 is equal to ID minus I1. So I3 value already we know, previous expression derivation we made it. And IC, what is IC current? This direction, whatever ID current is there, it is passing through this way. You can see, so it is an opposite direction, that's why I made it as a minus I2 and also called as a minus ID, because this total current passed through the ID, so that is going to I2, so therefore minus sign opposite. The rest of the walls, 1, 2, 3 only conducting, rest of walls are what? 4, 5, 6, so therefore you make it zeros. And just before slide, VA, VB, average of that will give as a VP. Then I mentioned now minus EC by 2 are also called as a minus 0.5 into EC, that you can mention it. And rest of the voltages VC, VN, because in this connected to the N neutral pole, then that is equal to EC. So EC is nothing but EM cos omega t minus 180. Just simplification, this minus 180 replaced by the minus cos omega t. So then VD is nothing but a VP minus VN. Already we know what is the VP. This is the VP, and VP minus VN. VP is nothing but a minus 0.5 EC, and EN is nothing but minus EM cos omega t, and this is a 0.5 EM cos omega t. So take it common of EM, then 1 plus 0.5, that is equal to 1.5. So 1.5 EM cos. So voltages, conducting voltages are 0, because V1 is conducting, V2 is conducting, V3 is conducting walls. So conducting voltages are 0. Rest of the voltages where it is connected, anything, let it be, I will explain one. 4, let's consider 4. Where it is connecting? It is connecting to the N, anode is connected to the N, and cathode is connected to P. Therefore, what is your output voltage? Vn minus Vp. Vn minus Vp is nothing but a minus Vd. Vd is nothing but a Vp minus Vn, and this V4 is nothing but a Vn minus Vp. So that is equal to minus Vd over. So that now you can easily find the average expression because I know what is 1 and 2 is conducting, what is the expression we already derived, and that is a non-overlap case, and with overlap case these are the VDs. So now we know final VD is equal to without overlap case 1 2 is conducting what is expression and integrated that portion, and plus 1 2 3 is conducting this portion integrated will get it as average. So that we'll see in the next class. Then you can give your attendance and leave. If you have any doubt, you can ask, otherwise you can give your attendance and leave.